So today is Friday. It's our 7th lesson of the semester. We're going to talk about additional properties of lines. Coming up, you can see not too far into the future is our second quest. Looks like October the 2nd, whenever that is, like a week and a half-ish. So that will be here before we know it. But anyway, today we do additional properties of lines. So let's jump in on page 54. In this lesson, we explore properties of horizontal, vertical, parallel, and perpendicular lines. So 4 different kinds of lines we're going to talk about today. And then just a reminder here in number 0 is that, and we talked about this the other day, we're not going to cover something called functions, but it is in your book. And so if you see something like, consider the function f parentheses x equals 3x minus 2, you're just going to translate that in your mind. Function becomes equation, f parentheses x becomes y. And so that translates to consider the equation y equals 3x minus 2. All right? Okay, let's take a look at number 1. Part A says consider these points, and then we're going to plot them in part A. So 7, 2, negative 4, 2, and 0, 2. Let's plot those guys real quick. And then in part B, what word describes the line connecting these points? Horizontal. That's the word we're looking for. And horizontal lines is one of the things we're exploring today. Part C, write an equation for the line that passes through these points. Okay, so I know we have y equals mx plus b. I'm going to say that for any horizontal and vertical line, you are going to completely forget y equals mx plus b. You're not even going to use it. Just 2 special cases, and we're going to figure out their properties right here for any horizontal and vertical line. Take a look at those 3 points. They have something in common. What's the same for all 3? The y value. And how much is the y value for all 3? 2. And so you just have to say y equals 2, and that's the equation of the line. And I know we only plotted 3 points, but if you pick any point on that horizontal line, you can say for sure that the y value is 2, right? At every single one of these points. That's what they have in common. And so the equation is simply y equals 2. Let's go ahead and calculate the slope of the line so we can learn about slopes of horizontal lines. We've got 3 points. I'm just going to pick the first 2 points. I'll subtract this way, and I'll subtract that way. Which one goes on top, x's or y's? The y is on top. So on top, we go 2 minus 2. On the bottom, 7 minus negative 4. Upstairs is 0. Downstairs is 11. How much is 0 divided by 11? It is 0. And so this is a fact. The slope of every horizontal line is 0. And that makes an awful lot of sense to me for a couple of reasons. Number 1, we know that slope is supposed to be rise over run, yes? As you go from one point, let's pick the point we had, 7, 2, and then negative 4, 2. So we went from this point right here all the way over to that point. How much did we rise? Not at all. How much did we run? 11, but who cares? If you don't rise at all, your slope is going to be 0. Rise on top. 0 divided by anything is going to be 0. The other reason this makes sense to me is that you know that the slope of every uphill line is what kind of a number? It's always positive, right? And the slope of every downhill line is what kind of a number? Negative. And in between the downhill lines and the uphill lines is one line that isn't either one. It's this one. And what's the only number that's in between all the negative numbers and all the positive numbers? The 0, right? So it jives, right? 0 is right there in between. Horizontal is right there in between. Okay, let's take a look at the other case. Let's go ahead and plot these points on the graph, 4, 2, 4, 5, and 4, negative 3. Part B, what word describes the line connecting these points? That is vertical. Some folks miss the last two letters. They misspell the last two letters of vertical. It is A-L, not L-E. And let's write the equation. What do they have in common? The x is 4. X equals 4. That's the equation. And in fact, the equation of every vertical line is x equals some number. It's just whatever number the x coordinate happens to be. And let's calculate the slope here. M equals, all right, so again, I'll pick my first 2 points. I'll do 2 minus 5 and 4 minus 4. And again, the y's go on top. So 2 minus 5 above, 4 minus 4 below. 2 minus 5 is -3. 4 minus 4 is 0. What can you say about the fraction -3 over 0? So saying no slope is really common. I want to avoid saying it that way, and I'll explain why in just a moment. But what can you say about that fraction? It's undefined, right? You are not allowed to divide by 0. You've been trained from a young age. You cannot divide by 0, and it is still true. And we call this guy undefined. So what I want you to say is that the slope is undefined. And now I'm going to nitpick over here because Mark said it has no slope. And I totally get what you're saying, right? Like you can't talk about that slope in any concrete way, so it must have no slope. But the word no in English, like if I say I have no oranges, how many do I have? 0. So in some cases, the word no in English means 0. Yes, I have no oranges. But you don't mean when you say this has no slope, you don't mean it has 0 slope. 0 slope was the horizontal line that we did up above. So that's why I don't want us to say no slope, because it might suggest 0. Okay, so we got it. And let's summarize. There are exactly 4 things I need you to know about horizontal and vertical lines, and they are written right down here. The equation for a horizontal line, every horizontal line, has the form y equals some number. The slope of every horizontal line is 0. And then on the other side, the equation for a vertical line has the form x equals some number, and the slope of every vertical line is undefined. Right? Only 4 things you need to know. Okay, on the next page, we're going to skip 4. You can read that one later on. Let's jump to 5. And I'll show you exactly the kind of question I need you to be able to answer. Find the equation of the line that has m equal to 0 and passes through 3, 2. So I'm telling you the slope is 0, and I'm giving you a point that this line hits. Okay, so we're going to play detective here. We see m equals 0. That's one of the 4 facts on the previous page. What can you say about a line where the slope is 0? All right, so this translates to horizontal, right? Slope is 0, it's horizontal for sure. Next piece of the puzzle. In the other sentence about horizontal line, it tells us the equation of every horizontal line. Is it x equals a number, or is it y equals a number? It is y equals some number. I'm just going to use the number sign there. That's what it says. And then finally, I just have to figure out what the number is. And I have a single point, and I just have to identify how much the y is at that point. How much is it? 2. That's the equation of the line that we're talking about. Y equals 2 is the equation of the line that has a slope of 0 and passes through the point 32. Question on that one?
Yeah, I just don't get how you.
So go on the previous page at the bottom, and which sentence is it? It's the second one here. The slope of every horizontal line is 0. So if you see a slope of 0, you immediately translate to, oh, then it's vertical. Right. And like I said, there's only 4 things you have to know about horizontal and vertical lines. And on our next quest and our first test, you're just going to write those things on your cheat sheet, right? Like I don't want you to guess. You see slope 0. You say, oh, is it horizontal? Is it vertical? You'll have it written down right in front of you. You just have to make sure it's there. Okay. All right. So that's everything about horizontal and vertical lines. And let's take a look at part number 6 here. So I've got 3 lines graphed. And what special relationship appears to be there for those 3 lines? Like a geometry relationship. Looks like they are. Yeah, so they do have that. We're going to come to that in a second. What does it appear to, what appears to be true about those three lines? Looks like they're parallel, doesn't it? Yeah. And it's probably hard to read the equations of the lines on your paper, but if you look up here, we can read them okay. So y equals 2x plus 4, y equals 2x minus 1, and y equals 2x minus 8. And what's the same in all three of those equations is the slope, right? The slope of all three of these is that 2 right in front of the x. And it turns out that that gives us the only fact we need about parallel lines, is that lines are parallel if their slopes are equal. And if two lines have equal slope, they are parallel. So that is written right there in number 7. Two lines are parallel if their slopes are equal. And I want this to make sense. Again, you're going to have it written on your cheat sheet, but I want you to buy into it. Look, when we say the slope is 2, so the slope in this case is 2, which I'll write as 2 over 1, which we know is a rise over a run. So we rise 2, we run 1, yes? That's the slope of that line. Okay, I can't start at that exact same point, but maybe I start down here. Rise 2, run 1. And over here, we'll start on this guy. Rise 2, run 1. And so because slope is a measure of steepness, if the steepness of the three lines is all the same, then of course they're going to be parallel. They just have different starting spots. Okay, so that's everything to know about parallel lines. And then finally, everything to know about perpendicular lines is down here. Okay, let's take a look at these two lines, and we are going to calculate their slopes real quick. All right, so to find the slope of the uphill line, let's go ahead and use this point, 0, 4, and then can you guys help me out? Is it -1, -1? Yeah, is that one on the line? Okay, so I'll use my same slope triangle as before. We're going to rise a bunch, and then we're going to run a little bit. Rise over run. What's the rise? 5 in this case. Over what's the run? 1. And both positive, right? Up and to the right, both positive. So the slope of that one is 5. I'm going to leave it as 5 over 1. Let's pick 2 points on the downhill line as 0, -3. Do I have that right? And then 5, -4. Yes? Okay. And let's go ahead and follow this path right here. Slope of this one, what's the rise? Is 1. And the run? 5 on that one. Are they both positive? -1, right? Because we fell. So we went down, so that's going to be a -1 upstairs. And then how about the 5? Positive or negative? Positive. We went to the right, so -1/5 is the slope there. Okay. So perpendicular lines means these lines meet at what kind of angles? At 90-degree angles, also called right angles. Okay, so we know what perpendicular means. Now we're looking for a relationship between the slopes. If I tell you the slope of one line is 5 and I want the slope of the perpendicular line, there's 2 things you need to do to this 5 to turn it into the right slope. What's one of those things? You got to flip numerator and denominator, right? Reciprocal. 5 over 1 became 1 over 5. What was the other change? That slope was positive, and we need to make it negative. If I gave you -1/5, and I said find the perpendicular slope, you would take that negative and make it positive. And I want that to make sense too. If I got 2 perpendicular lines here, my arms, one of them is uphill. What kind of a slope is that? Positive, and the other one is downhill, which is a negative. So if one's positive, then the perpendicular is negative. And that remains true even if the one that was positive becomes negative. Like one of these is positive and one of these is negative no matter what, except for the horizontal vertical, but we've already talked a bunch about those anyway, okay? So perpendicular lines, one positive slope, one negative. So it's up here in bold. It says if 2 lines are perpendicular, then the slope of one is the opposite reciprocal of the slope of the other. Opposite means change sign, reciprocal means flip it over. Those are the 2 things you do to get perpendicular slope. Okay, so the activity is on the next page. The first couple, actually the first 3 questions are just a review from our previous section on y equals mx plus b, and you are going to use y equals mx plus b a bunch in this activity. Starting at number 4, though, we see the word vertical, and then that's going to be kind of the new stuff, and you'll see parallel and perpendicular things coming up too. And so the first 3, just standard y equals mx plus b from before, and then you'll get to the new stuff. Raise the flag if I can help.